Hi, hello everyone. So we're going to continue on with our exploration of the very basic x squared plus y squared is equal to r squared. So that's a circle with a center of 0, 0, radius of r. Okay, so that's what we're going to have a gander at, and we'll just see where we get there with them, as they say. So we'll write down a few, and I'm going to use the 3, 2, 1 pause method, and you're going to give it your best shot. So in all these cases, I want you to write down the center of the circle and the radius. Okay, so let's go with them then. All right, so we have 3 examples here. I'm going to do a 3, 2, 1 pause. You're going to write down the center and you're going to write down the radius. Okay, 3, 2, 1 pause. And we're back. Okay, so hope you got them right. So center is going to be 0, 0. And the radius is going to be, well, if I had to cross by 9, I'll get 4 over 9, and the square root of 4 over 9 is 2 over 3. Okay, similarly here, center is 0, 0. If we divide across by 16, I get 49 over 16. The square root of 49 over 16 is 7 over 4. And same thing here. Let's divide across by 25. We get 100 over 25. The square root of 100 over 25 is 10 over 5, which is 2. Okay, so that's just a quick little warmer-upper. Hope you got them right. So we'll just play around again with some other ideas. Okay, with let's think trying to find nice easy ones for you to try. Okay, here we go. We'll draw a circle, center 0, 0, and a point on the edge of 2, 3. And I want L1. Okay, and I want the equation of L1. Okay, so I want the radius of the circle, and I want the equation of L1. Okay, so 3, 2, 1, go. And we're back. So let's do the easy bits first. So how do I get the radius of the circle? Radius of the circle, I can just get the distance formula. Okay, so the distance formula, let's use 2 and 3 and 0 and 0, x1, y1, x2, y2. And we have the square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's the square root of minus 2 squared, which is 4, minus 3 squared is 9, square root of 13 is one of our old friends. It comes up quite often. So root 13 is the distance. Okay, so the equation of that circle, if you were asked for it, is x squared plus y squared is equal to 13. Not root 13, because it's r squared. So we weren't asked for that. We were asked for the, apart from the distance, we were asked, for the radius, we were asked for the equation of this line. So how do we get the equation of the line? Well, let's just have a gander at it over here. Okay, what do we need for equation? We need a slope and we need a point. Well, we have a point, 2, 3. There's your x1, y1, but we need a slope. Okay, so if I get the slope of this, what do we know about a point that's tangential to a circle? Okay, they're perpendicular slopes. That's a right angle. So get the slope of this and we get its perpendicular, and you've already got the slope of this. So the slope of this, y2 minus y1 over x2 minus x1 is 3 over 2. So it's minus 2 over 3 is the slope we're looking for. So y minus y1 is equal to minus 2 over 3 on x minus x1. Distribute the 3y minus 9 is equal to minus 2x plus 4. Bring everything to the same side, so you got a positive x. 2x plus 3y minus 13 equal to 0. Done. Okay, so very simple one, very easy, very accessible, something you should all be able to do. Okay, I suppose that's the key to a lot of these things. Are you able to do it? Okay, we'll do another one now, but this one maybe we use a perpendicular distance formula or something on it, just to have a bit more kind of fun. So circle, we get a little point. I don't know why I favor the top right hand corner, but anyway I do. So let's throw an old equation at this one. 3x plus 2y minus 6 equal to 0. So we have a little equation. We've got a center of 0, 0. And what we want to do is we want to find the equation of this circle. So obviously it's going to be in the form of x squared plus y squared is equal to r squared. Problem is we don't have the r. Okay, but we can get it using the perpendicular distance. Okay, so let's use our perpendicular distance formula. So perpendicular distance formula, let's find it. What is it? Well, first of all, let's write down what we have. We have 3x plus 2y. What have we got? Minus 6 equal 0. So there's your A, your B, and your C. And we've our point, 0, 0. That's your x1 and your y1. So what does our perpendicular distance say? Our perpendicular distance says that it's A times x1. So 3 times 0 plus 2 times 0 minus 6 over the square root of A squared plus B squared. Oh God, it's 13 again, isn't it? Okay. So you've got minus 6 over root 13, which is 6 over root 13. 6 over root 13 is the distance. Bing-a-bang-a-boom. So that is a 6 over root 13 is the distance. But now let's put that to our value. So it's x squared plus y squared is equal to 6 over root 13 squared. Okay, so 6 over the square root of 13 squared is this looks weird, 2 and 10 26 36 something like that, 36 over 13. Okay, that's what it is. So it's x squared plus y squared is equal to 36 over 13. Okay, so that's it. So there's your perpendicular one. And then you could work backwards if you were asked that. If you were given the r value and given that, you could prove that that's 0, 0 just by slotting them into your... And you've done this a few times with your perpendicular distance type of thing. You have done this a few times, so there shouldn't be really any issue of it. Okay, so what are we going to go on to? We're going to start talking now about, well, what happens if it's not 0, 0? So if it's not 0, 0, let's see how we'd arrive at some other number. So I'm going to do this more in a theoretical way, first of all, before we actually go on and look at it. Ding-a-ding-a-ding. Okay, so let's draw one that is 0, 0. Try and get this as accurate as possible. Actually, no. Before I do that, I'm going to make this super duper accurate. Okay, as accurate as I can make it anyway. So there's 1 unit, 2 unit, 1 unit, 2 unit. That was pretty accurate. Okay, so and we'll do the same thing up here. 1 unit, 2 unit, 3 unit. Just to go super duper accurate on this. Okay. So it has a radius of 2 centimeters. Okay, that one there. Okay, now watch this. Let's funk this up a little bit. Okay, let's go out to 4, and let's go up to 3. Somewhere there. Change the distance on this. So I'm just going to redo it. So this will be the same circle. I just kind of moved it a bit. So we know that this is x squared plus y squared is equal to r squared because the center of it is at 0, 0. But what happens if the center, in this case, the center of it is at 4, 3? Okay, that's what's there. Okay, it's 4, 3. So how do we accommodate for that? Okay, well, if you think about it, in order to make that be that, wouldn't we have to pull this down by taking away 3 and pull it across by taking away 4 in order to translate that point into that point? Wouldn't that make sense to you? So in other words, you'd bring the circle down to this line, so it's got the y value would go to 0, so it'd be 4, 0 if it was there. So if I redrew it down here, okay, it'd be 4, 0. And then if I track it back to here, the 4 would eventually go to 3, to 2, to 1, to 0, and it'd be just on. So bringing it down and bringing it across allows you to do that. So when you think about it, what you're really saying to it is, it's really this x, the extra bit that needed to take it down, okay? And we call that h. And we're going to square it because we have to square the x value, okay? Plus y minus the bit that you had to pull down to get the y down to 0 equals r squared. So you can see how they're married up. Look, I'll show you them. This one is this. You've just shaved off a little bit to bring it back to the 0, 0 mark. And this one is this. So you've just shaved a bit down. So you brought it down by taking away a bit from the y. So whatever h and k center you have, by popping it in there, you've generated the same formula that would have generated, except it's not at 0, 0 anymore. But you're using the 0, 0 formula to generate the new circles formula. So I'll show you. Okay. Let's say I have a center is equal to 3, 2, and the radius is equal to 4. So how would that look like in our new scenario? Okay. Well, look, it's going to be x minus 3 to be squared plus y minus 2 to be squared is equal to, well, what's r squared? 16. So this becomes the new version of the formula. Now, what's cool about it is every piece of information that you use to build it is in there. So for example, the 3 is in there, the 2 is in there, the 4 is in there. You just have to know how to reactivate them by looking at what you did to get that 16. You squared a number so you can get the root or the radius back. The trick with these is the y value will always be the opposite sign to what you see in there. So if you see a minus in there, it must have been a plus. If you see a plus in there, it must have been a minus. Same here. Now these formulas are in the log table, so don't worry, okay? But in this case, if you have a negative 3, it must have been a positive before it went into the formula, because the formula has a built-in negative, because you remember you're taking away a bit to get down, taking away a bit to get back. That's what you're kind of doing, okay? Now it's a very important piece of kit, okay? Now,